Megan doesn't feel like a very nice texture.
Today we will be making a baby lava.
What we need for this experiment is vegetable oil, 275 milliliters of water, food coloring, salt.
I'm so clever.
The beaker
Should we do it over
main
there?
base for this experiment. It will be the lava lamp itself. The beaker is not the most precise measurement for liquids. However, the graduated cylinder, which as you can see marks off everything to the millimeter, is.
First in this experiment, add the vegetable oil to the water.
I'm ready.
As you can see, vegetable oil floats to the top because it has a lower density than the water.
How much? We need 50.
Now we're going to add a few drops food coloring. As you can see, it does not do anything. Now, we're going to add some of the salt.
Actually, it kind of smells like the fair a little bit. No, with the kettle corn. Alright, I think I'm ready. Where are we going to set that?
It breaks down.
We don't need to show them how water.
Notice that the oil now goes to the bottom of the beaker. This is because the salt is more dense than water and drags down the oil because it mixes in it. Also notice that the food coloring did not go to the color the oil because it does not mix with it. Now that it is dragged through, it will color the water. Alright, now as you can see, the oil is slowly going back up to the top. That's because even though it's been dragged down by the salt, which has a higher density than the water, so that is why it dragged the oil down with it. Thus releasing the food coloring. Anyways, but it is going back up because it still has a lower density, so it's going to fight its way through the water, go back up to the top, and float on top because of the density. Now, also notice that if I move this a little bit, the oil, it's moving slightly more than the water is. That's because there's a lesser viscosity, which means it's not as viscous, it's not going to move as, it's going to move more, than other things. Say, as in clay, when it has a very high viscosity, it's not going to move much, so it's still a liquid.
So what do you want me to say?
The salt, the oil starts to break through the salt because salt is soluble, which means it can dissolve in liquids, but this time it is dissolving in the water, which is slowly allowing the oil to escape back up to the top and rejoin the other oil back up here.
We're starting with 450.
What we did here was we put salt water on the bottom, which has a higher density, than cold water, which is in the middle. And you can't really see it that well, but we had hot water, but it kind of blended in with the cold water, so that you can kind of see it with the dark green and the lighter green here. The hot water has a lower density than the cold water. The vegetable oil on top has a lower density than all of the types of water.
This is due to the fact that oil, though it takes up the same amount of space, is less dense because it has particles. Same thing with the salt water. But for the hot and cold water, anything that is cold becomes more dense because the particles are drawn closer together. So more particles take up the same amount of space. So the cold water will sink to the bottom, while the hot water will stick on top.
I'm going to explain to you what happens when a liquid is a solid. Right now, the particles in the solid are just moving around in a fixed position. And when it starts melting, it goes up, the temperature raises up, and so does the kinetic energy, which causes the temperature. And once it hits a certain point, then it stays the constant temperature while it's melting. Then it goes to liquid. It goes from a liquid to a solid. It starts freezing and goes backwards. And a crystalline solid is a solid that puts back when you hit it, or so. Amorphous solid is a solid that does not push back. A good example of that is glass.
Now you see, liquids. They will conform to the container, but they will not. But they have a fixed volume, which means they will not expand over the container. Liquids, unlike solids, their particles move past each other, kind of like gliding across one end of the football field to another. They have a higher kinetic energy than a solid, but lower kinetic energy than a gas. And when the temperature reaches a certain point, the liquid starts to go through vaporization, which can go in either boiling or evaporation. Once all of the substance reaches a certain temperature, it will then go to a gas. The same thing happens, though it's opposite, and condensation occurs, and it goes back to a liquid. Okay, now a solid can go, a gas can go from a solid to a gas. A gas can go to a solid instantaneously through sublimation. Sublimation is, sorry, it's the opposite. It's through deposition. In deposition, an example of this would be more of a dry ice, where when you have dry ice, it'll sublime to come back to gas as it slowly breaks down. After gas, it's plasma, and it gets there through ionization, which means the particles are extremely charged, and it's in fact so charged that an example of this would be lightning, and the way it gets back to gas would be deionization. In plasma, the particles are extremely hypercharged, and everybody seems happy to lightning.
A solid has a definite shape and a definite volume. Liquid has an indefinite shape and a definite volume.
A gas, it has an indefinite shape and an indefinite volume. Plasma has an indefinite volume and an indefinite shape. Alright, now this diagram is a heating and cooling diagram. It shows water through solid goes to a liquid through melting. A liquid goes to a gas through vaporization. Now this is important from when we stack the liquids because it shows that as this gets hotter, even though it doesn't actually directly show it, as liquid, as it gets hotter, it's going to become less dense as it gets more into a gaseous state. So that's why this is important in showing how the cold water was under the hot water, because it was less dense, it was more in a gaseous state, it was hotter, and it was less compact than the cold water, which was in a more condensed state, so it was more dense. It is also important to note that between this temperature and this temperature, the state of matter is not actually changing until the entire substance changes to the same temperature, which will then go up the ladder again.